Students, I will try to record a video just showing you a couple of examples of how to solve radical equations. The video might be a little bit long because I have several examples I would like to show you. So be patient with me. Hopefully this will be helpful. So we'll go from there. The first one that I have is, well, of course, we are solving radical equations. The whole idea is to isolate the term that contains the radical so we can quickly raise to the whatever power. In this case, of course, the index is 2. Here, the index is 2, so we need to square both sides of the equation. So I have 3x minus 2 square of that equals 5. We can quickly square to the left, square to the right. And on the left-hand side, we have 3x minus 2 equals 5 times 5, 25. Now is business as usual. We may add 2. So 3x equals 27. We might divide by 3. So x equals 9, and we are done. We should always verify the work, because sometimes we get funny answers. So when x equals 9, 3 times 9, of course, is 27, minus 2, 25. The square of 25 is 5, and indeed 5 equals 5. So the answer checks. Basic example. Let's try a second one. I hope I didn't go too fast. This will be the classical example when we have the term with the radical isolated and a positive number on the other side. So let's try another example with what I like to call with quote unquote noise. What if I have 3x minus 5 square of that, 3 times minus 8 equals 4. So in here we have some noise. We have 3 times the radical minus 8 equals 4. As we isolate the 2 with the radical, we may want to add 8 and divide by 3. Let's see what happens. And when I add 8, 4 plus 8 will be 12. And here we have 3x minus 5, 3 times that. Since I'm multiplying by 3, we perhaps can divide by 3. 3 over 3 is 1. So now we have 3x minus 5, radical that equals 4. 12 divided by 3 is 4. And now, as before, we can square to the left, square to the right. So we have 3x minus 5 equals 16. We proceed to add 5. 3x equals 16 plus 5, 21 divided by 3, x equals 7. Oops. We should always verify the work. When x equals 7, 3 times 7, 21, minus 5, 16. The square of 16 is 4. 3 times 4, 12, minus 8, 4, and we did 4 equals 4. Okay, notice that once again, after we isolate the radical, this is what we want to get. And this is what I like to call the classic example. So the radical by itself equals a positive number. So we may square, and then we solve the problem. Always remember the following, folks. Might as well let me share the screen. It states when we use the radical sign, it indicates the principal or the positive root. Always is the principal or the positive root. If an equation has a radical with an even index equal to a negative number, that equation will have no solution. So let's go ahead and try one example. Well, let me wait here for just 1 second. Just giving you some time. Let me stop sharing this. What about if we have the following? 2x minus 3, equal that, plus 5 equals 0. We may subtract 5. Now we have 2x minus 3 equals -5. Notice I have the square root equals to negative number, so this one has no solution. Let's say that we don't see it and we are, we may want to, if we want to continue, just to make sure, so I can square to the left, opa, I can square to the right, and I have 2x minus 3 equal, this was -5. -5 times -5, 25. We may add 3, 2x equals 28. We may divide by 2, so x equals 14. We will be happy because we got an answer. However, when x equals 14, 2 times 14 will be 20. Excuse me, 2 times 14 will be 28 minus 3, that will be 25. The square of 25 is 5 plus another 5 equals 10, not 0. This is what we say that we have. We could have stopped here when we have the square root equals a negative number, no solution. So here x equals 14 does not work. It does not satisfy the original equation. Let's try another one. What if I have the following? 5x plus 1 cube root plus 8 equals 4. We proceed to subtract 8. So 5x plus 1 cube root of that equals 4 minus 8, -4. In this case, we'll be tempted to say there is no solution. However, be careful. Let me go ahead and share the screen once again. Notice that we only care when it's negative on the right-hand side when we are dealing with the radical with an even index. Radical with an even index, equal to a negative number. Even index, negative number. In our case, notice that we have an odd index, so that's okay. So how do I get rid of the cube root? We just simply cube on the left, cube on the right, and we get 5x plus 1 equals -4 times -4, that's 16, and -4, that will be -64. We may subtract, we may subtract 1, so 5x equals -65, and now we just simply divide by 5, divide by 5, so x equals, I believe that's -13. And that will be the answer. You should verify it, but -13 will work. We have no issue in cubing it because it had we have an odd index, so we may proceed. If the index was 4, 6, 8 equals to a negative number, then we may say there is no solution. What if I have, well, let's look at this other example. The square root of x minus 2 plus 2 equals x. Once again, we want to isolate the term that has the root, so we may subtract 2. So we have x minus 2 equal x minus 2. We may proceed to square to get rid of the square root. So square to the left, square to the right. On the left hand side, we have x minus 2 equals x minus 2 squared. You can FOIL this, so that will be x squared minus 4x plus 4. We end up with a quadratic equation. We always solve quadratic equation by equaling to 0. So I want the x squared to be the positive. So it's better for me to subtract 1x and add 2. So x squared minus 4 minus 1x minus 5x. 4 plus 2, that will be 6. Now we're looking for factors of 6. That gives me -5. Of course, that will be x minus 3 times x minus 2 equals 0. Zero product rule. When x minus 3 equals 0, x equals 3. Likewise, when x minus 2 equals 0, x equals 2. So now I have two potential solutions. We should always verify to see if these numbers will work. Let's start with x equals 3. When I have here 3, 3 minus 2 is 1. The square root of 1 will be 1 plus 2. And the number we're testing was 3. Indeed, 1 plus 2 equals 3. So this one satisfies the original equation. Let's repeat the process when x equals 2. 2 minus 2 is 0. Radical 0 is 0. 0 plus 2 equals 2. So in this case, both numbers satisfy the equation, thus we accept both numbers. What about if we have the following? Just like the previous example, the goal is to isolate the radical so we can quickly square. Therefore, we should add x and subtract 2. So x minus 4 radical that equals x minus 2. Just like in the previous example, we may square on the left, square to the right. On the left, we end up with x minus 4 equals. When you multiply x minus 2 by itself 2 times, you get x squared minus 4x plus 4. Okay, once again, we got the quadratic equation. We should always equal it to 0. Therefore, I must subtract 1x, add 4. So x squared minus 4 minus 1, that is minus 5x. 4 plus 4 will be 8. I'm sorry, I wrote this incorrectly. It was x plus 4. Sorry about that. X plus 4 equals that. Okay, so that will be x plus 4. I do apologize. Now everything is okay. Factor. So now I add 1 and it will be minus 4. So that will be 0. It didn't factor. So it was x plus 4. Okay, perfect. So now, of course, we can factor this guy. We can factor everything x minus 5 equals 0, 0 property, x equals 0, or x minus 5 equals 0, x equals 5. Two numbers that we need to double check. So let's see what we have. Let's start with the 0. When x equals 0, 0 plus 4 is 4, radical 4 is 2. We are testing x equals 0, so 2 minus 0 plus 2 is not 0. So thanks, but no thanks. Let's go ahead and try the 5. 5 plus 4 will be 9. Radical 9 is 3. Okay, we are testing x equals 5. So 3 minus 5 plus 2, yes, indeed 0. 3 plus 2 is 5, minus 5 is 0. So x equals 5 will work. X equals 0 does not work. Sorry for the mistake I made. Remember, just check the original point was x plus 4, not x minus 4 when I wrote it originally. Two more examples, I should say. So let's start with this. Let's try this one. Notice that I have two radicals. So the idea will be to isolate one, we square, then isolate the second radical, and we square again. So I like to start with the more complicated one. So let's go ahead and isolate this guy, the square root of x minus 9. Therefore, I must add radical x both sides. So on the right-hand side, I end up with 1 plus radical x. On the left-hand side, I just simply end up with x plus 9 radical that. At this point, we can just simply square left, square to the right. On the left-hand side, I have x plus 9. Here I have 1 plus 2 radical x plus x. Now I need to isolate the term that contains the radical. So let me proceed to subtract 1 and subtract the x. X minus x is 0. Then I said we subtracted 1, so it'll be 9 minus 1 is 8 equals 2 radical x. Here, since this is 2, this is 8, we may afford to divide by 2. Sometimes if you don't get a fraction, don't divide, just simply square. In this case, it's 4 divided by 2. So now I have, of course, 4 equals radical x. So we may square, so 16 equals x. Is 16 the answer? We don't know. Let's go ahead and verify. Yeah, we verified. When x equals 16, 16 plus 9 is 25. Radical 25 is 5. When x equals 16, radical 16 is 4. Last time we checked 5 minus 4 equals 1. So it does verify, so we accept the answer, x equals 16. Last example, very similar to the one we just finished. Radical square root of 3x plus 4 minus radical x equals 2. Let's add radical x. So I have 2 plus radical a. Here I have 3x plus 4. And now we square left, we square right. On the left-hand side, we have 3x plus 4 equals. Some of us struggle multiplying 2 plus x by itself 2 times. So I'm going to do a quick video on that one, just so you verify it. So you can review it, how to FOIL this guy. So I have 4 plus 4 radical x plus x when you FOIL this guy. Now what do we have? I need to isolate this term. So we may want to subtract 4 and subtract 1x. So 3x minus 1x, that is 2x. 4 minus 4 is 0, bye-bye, equals 4 radical x. Notice here, folks, if I divide by 4, I'll be introducing a fraction. So it's up to you. I prefer not to. So what I'm going to square on the left, square to the right. So 2x times 2x will be 4x squared. Here, be careful. You need to distribute the 2 to each term. So 4 squared is 16. And then radical x squared, that will be x. No big deal. Quadratic equal to 0. So yeah, before I do that, it's easier just to divide by 4. What the heck? Don't divide by 4. Don't worry about it. So let's go ahead and equal it to 0. So you have 4x squared minus 16x equals 0. Now we can factor the greatest common factor, which is 4x, parentheses, x minus 4 equals 0. You may verify it. So now what do we say? As always, the 0 property rule, 4x equals 0 or x minus 4 equals 0. 4x equals 0, x equals 0, we divide by 4. X minus 4 equals 0, x equals 4. We have 2 potential solutions. Let's see what we have. Let's go ahead and try x equals 0. 3 times 0 is 0 plus 4, 4. The square root of 4 will be 2. When x equals 0, the square root of 0 is 0. 2 minus 0 equals 2. So x equals 0, checks. Let's go ahead and try 4. 3 times 4 is 12. 12 plus 4 is 16. Radical 16 is 4. When x equals 4, the square root of 4 is 2. 4 minus 2 is 2, and 2 equals 2. So we accept both numbers. That will be the answer. This will be 2 solutions, 0 and x equals 0, x equals 4.